A very good afternoon to all the students. So, up to the last session we have discussed the concepts related to the mathematics that are useful for the cryptography, right? So, in today's session we are going to start with a new topic which is called as modern symmetric key ciphers. So, in this topic we are going to discuss these techniques which is called as the substitution technique or transposition technique. We are not going to give any examples, right? So, we are more concentrated towards what these components of the modern block ciphers are, and what are these block ciphers and how do you make use of these block ciphers with respect to the substitution and transposition, and what are these product ciphers, and what are this particular topic is very important, the components that are related to the modern block ciphers. Are you able to hear my voice, right?
Yes, sir. Yes, sir.
Okay. So, later we will discuss the concept of product ciphers, which is a very simple topic, and after that we will discuss the two classes that are present under this product ciphers, and finally we will end up the session with a discussion on the attacks on block ciphers. So, this is how various topics that are related to this modern symmetric key ciphers are, right? So, yesterday we have gone through the lab session where you have discussed a concept called as substitution. Can anybody tell me what do you mean by substitution?
We're now unmuted. We substitute the characters of the key with predefined characters.
Right. So, it is not the predefined characters, but substitution, as the name itself is suggesting that we are going to substitute the characters of the input text with some other characters or some other symbols or anything you can use, right? So, we are substituting the characters of the input text with some other characters and symbols. That is called as the substitution. Can anybody give me one example of this substitution method? Yesterday you have gone through the example also. What program you have done using this substitution?
We defined a character array P, sir.
No. Give me an example. Give me an example of substitution. That's it. Yesterday you have gone through a concept called as Caesar cipher. Have you gone through this Caesar cipher or not?
Yes,
so you arrange the alphabets in the alphabetical order, and then you replace every character of the input text with +3. That means you move forward 3 characters and then you will replace it, right? For example, A is replaced with D. Similarly, C is replaced with G, something like that. So, you are substituting the characters, the input characters with some other characters or symbols. That is called as the substitution method. So, we have other key cipher which is called as the transposition key cipher or transposition cipher technique. What do you mean by transposition? The name itself is saying that you are going to change the position of the characters, right? For example, yesterday you have taken one text like hello, and using this Caesar cipher, what is the text you got it here? Let us take the key size as 1, right? Let us take the key as 1 +1. So, how do you substitute this hello with other text? H is replaced with
I, sir.
I. E is replaced with
F, sir.
F. L with
M, sir. M, sir. O, C, sir. P, sir.
So, this hello is being replaced with these characters. That is called as substitution. So, in substitution, you are going to change the character. or you can change, you can also call it as you are going to change the face value of the character, right? H is replaced with I, E is replaced with F, L is substituted with M, like that you are going to change the character. But in transposition, the name itself says that you are going to change the position of the input text. You are not going to replace the characters, or you are not going to substitute the text. You are just going to change the position of those characters. For example, let me take the same text, hello, right? I will place this O as the first letter, H as the fourth letter, and E as the second letter, and this L as the fifth letter, and this as the second, right? So like this, O, E, L, H, L. You can observe here that this input text consists of the same characters here also, right? So it is O, E, L, H, L. So this is called as the transposition. So you should know the difference between the substitution and the transposition. Substitution is where you substitute the characters with other characters, and transposition is you make use of the same characters but you will change the position of those characters. Is it clear up to this point?
Yes, sir.
Yes, sir.
So coming to the title of our discussion, which is the modern symmetric key ciphers. We know what is this cipher is. What do you mean by cipher? Anybody? Can anybody tell me what do you mean by cipher?
The code which is encrypted, sir.
Yeah. So correct, Amma. So during the encryption process, you are going to convert the plain text into the cipher text. So that is, whenever you convert one text or the plain text into other format, that is called as the cipher. Here we are going to call them as ciphers. And these cipher techniques are broadly classified into two categories. This is very important topic, please concentrate. So these ciphers are, the cryptography is broadly classified, or they are based on two important techniques. One is the symmetric key ciphers, or you can also call it as symmetric key cryptography, and the second one is the opposite of this symmetric, which is asymmetric key cryptography. So what do you understand by the term symmetric key cryptography? The name itself is saying that it is symmetric key, that means same key. So we have two techniques in this cryptography. What are those two techniques? One we will do it at the sender side, and another we will do it at the receiver end. So what is the technique we use at the sender side?
Encryption, sir.
It is encryption, right? And at the receiver end, you will be doing the decryption technique.
Decryption.
So in order to convert one plain text into the cipher text, we should use a key here. Key is very important component in the cryptography. And similarly, in order to convert the cipher text back into the plain text at the receiver end, we have to use a key here also. So encryption involves a key, and similarly the decryption also involves a key. Right? See here. If both the encryption and decryption are using the same key, then we call such type of cryptographic algorithms as symmetric key cryptography algorithms. Symmetric in the sense same. So if we use the same key for both the encryption and decryption, we call such type of cryptographic algorithms as symmetric key algorithms, or symmetric key cryptographic algorithms. And what do you mean by this asymmetric key? We know that both encryption and decryption make use of keys, right? But if the encryption makes use of one key and the decryption makes use of the other key, then we call such type of cryptographic algorithms as asymmetric. Asymmetric in the sense different. So they are going to use the different keys for both encryption and decryption. Is it clear up to this point? This is enough up to our discussion point of view. Right. So symmetric key cryptography makes use of same keys for both the encryption and decryption, whereas the asymmetric key cryptography makes use of different keys for encryption and decryption. Is it clear up to this point?
Yes, sir. Sir.
So right now we are going to concentrate only on the symmetric key cryptography. So whatever discussions we take in this particular session or for the coming particular sessions, we are going to discuss only on the symmetric key, right? So we are going to use the same key for both encryption and decryption, right? We'll see when time comes. We will also discuss the differences between the symmetric key and the asymmetric key. Don't worry, right? So I think you are clear about the topic which you are going to discuss, right? We are going to discuss the symmetric key ciphers and that too the modern symmetric key ciphers. Usually in the traditional key ciphers they are going to use one technique, and in the modern cipher techniques they are going to use some other technique. So we are going to concentrate only on the modern symmetric key ciphers. So in this particular topic we have various topics like substitution, transposition, and block ciphers as permutation groups, components of a modern block cipher. All these things we will discuss, right? Is it clear up to this point?
Yes, sir. Yes, sir.
So as discussed, we have these particular topics like block cipher as permutation group, components of a modern block cipher, product ciphers, what are the two classes of the product ciphers, and what are the attacks that can take place on the block ciphers. These are the main important topics which we are going to discuss regarding this modern block ciphers, right? And coming to the introduction part, right, traditional symmetric key ciphers use character oriented ciphers, right? So previously the symmetric key ciphers, they are going to use the character oriented ciphers. Can anybody tell me what do you understand by this term character oriented cipher? What do you understand by this term character oriented ciphers? Anybody?
No, sir.
Okay. So the name itself is saying that you are going to make use of the ciphers which are character oriented. How do you represent a character? How many bytes are required? At least you tell me that one.
8 bits, sir.
1 byte, right? Which is equal to 8 bytes. 8 bits. 1 byte is equal to 8 bits. So we are going to convert the plain text into the cipher text with respect to each and every character. Such type of ciphers we call them as character oriented ciphers, right? But how do you store information in the computers? Is it in the byte level or bit level?
Bit level, sir.
We are going to store it in the bit level, right? So computers need bit oriented ciphers. There is a special purpose why we require this bit oriented ciphers. Means, for example, if you have a text like hello, right? So you can take this entire character H, or you can take this entire character E, L, L, O, like that. So you can take each and individual character and you can convert that character into some other format, or we can convert it into ciphertext, right? So this is with respect to the byte level, 1 byte or 1 character. This is how happens it with respect to the textual data. And my question is whether we have only textual data that we deal in the real applications, or do we have any other format other than the text? Yes or no? Do we have only textual data, or do we need to deal with different formats of data in the real world
Different
applications?
forms of data, sir.
Different forms of data will be there, right? So it is not mandatory that you always have the textual data. So you may have numbers, or you need to deal with numbers, or you need to deal with image files, or you need to deal with the audio files, or you need to deal with the video files. So different formats of data that are available for the real world applications. So you need to convert these images into a format which is not understandable by the third party users, or you need to convert the audio file into another format which is not understandable by the invaders, right? Similarly, you need to convert this video to other formats. So there are a lot of data that we are going to deal in the real world applications, right? So if we are dealing only with the text, then it is sufficient that we have these character oriented ciphers. You just take each and every character and you convert it into other format, that is enough. But when you are dealing with the computers, and when you are going outside the world, or going into the world, real world applications, you need to deal with different formats of data, and they are not represented as characters. So if you take image, can anybody tell me how it is stored, how the image is stored? Any idea?
No, sir.
So this image is represented in terms of pixels, right? For example, 256, 255 cross 255 pixels, like that, right? So these are nothing but bits. Every pixel will have some bits, right? Similarly, how do you store this audio? It is also in the form of bits only. How do you store this video? It is also in terms of bits only, right? So when you are dealing with the computers, it is mandatory that you should be in a position to manipulate at the bit level itself. You should be in a position to convert the bits into ciphers. So computers need bit oriented ciphers. Now is it clear what this character oriented cipher is and what this bit oriented cipher is?
Yes, sir. Yes, sir.
Right. So any type of data you take in the computers, whether it is a textual data or number format data, graphics, images, audio, video, anything you take, that should be converted into bits. Therefore, there should be some provision to deal with the bit oriented ciphers, right? Or there should be some provision to deal with the bits. So that is the reason why we have this bit oriented ciphers. So we need to convert all these types of data into streams of bits. Is it clear?
Yes, sir.
So when text is treated as at the bit level, I told that one character is equal to 8 bits. So when you are dealing with the textual data, you need to convert the characters into bit level. We know that each character is consisting of 8 bits or 16 bits. Some computers, they will support the 16 bits also, but at max we will be dealing with this 8 bits, right? So this is the difference between the character oriented ciphers and bit oriented ciphers. So traditional symmetric ciphers, they use it to deal with the character oriented ciphers, but when you are dealing with the computers, we need everything in terms of bits. Therefore we need to have the bit oriented ciphers, right? So this is just the introduction part of what these character oriented ciphers and bit oriented ciphers are. Now coming to other term, which is called as a block cipher. So what do you understand by the term block cipher? Any idea? What do you understand by the term block cipher?
No, sir.
What do you understand by this block? We know what this cipher is. You know what this block is. What is the general meaning of the block? What is the general meaning of the block?
Group of data
Restrictions है block.
Right. So when you group something, then we call it as a block. Right. Similarly, when you group some amount of bits, then we can call it as a block. So modern cipher techniques, they used to have, they are going to deal with the block ciphers. So a block is nothing but a combination of bits. It's not restricted to 8 bits only, it's not restricted to 16 bits, right? So in general, a block will start with 64 bits. In general, it is also not mandatory, but when we consider a block, it is a tradition, or it is a convention that we treat the 64 bits or more as one block. Right? We are not going to deal with 8 bits, we are not going to deal with 16 bits. So when we deal with these 8 bits and 16 bits, what is that cipher called as?
block cipher, sir.
No, 8 bit and 16 bits ciphering is called as character cipher, or else we can also call them as stream ciphers. Right. This is the traditional technique which we are going to use, but in the modern techniques we are going to use the block cipher. That means we are going to combine more number of bits to form a block, and we will take this entire block and convert the entire block into other format. So that is the difference between the block cipher and the character cipher. In the character cipher, you are going to take each and every character and you are going to convert it into the cipher text. But here in the block cipher, you are going to take a block of bits which is around 64 bits or more, and the entire block is converted into a cipher. This is the technique we are going to use in the modern day block cipher technique. Is it clear up to this point?
Yes, sir.
Right. So coming to the introduction part of the block cipher, symmetric key modern block cipher encrypts a n-bit block of plain text or decrypts a n-bit block of ciphertext. There is no difference between conceptually there is no much difference between this block cipher and the character cipher. Character cipher, they will treat the 8 bits or 16 bits as a single unit, and they will convert that single unit into the ciphertext. Whereas if you consider the block cipher, you are going to treat n bit as a single block. This n can be 64 or more than 64 also. Anything is acceptable. So you will take this n bits as a single block and you are going to convert that block into a cipher text. That is the only difference we have, right? So the encryption and decryption algorithm makes use of a key bit, k bit key. So as I told that any cryptographic algorithm you take, when you want to perform the encryption or when you want to perform the decryption operation, then you require a key for it. So the key, we will see what is the size of the key should have in this substitution technique, and what is the size of the key that a transposition cipher will have. All these things we will discuss, but at this point you please remember that any encryption or any decryption you want to perform, that requires a key, right? So that key can be k bit size, that k can be equal to n or more than n, that everything we will discuss. Remember that there should be a key for encryption and decryption, right? And what is this decryption algorithm? This is nothing but the inverse of the encryption algorithm. So you write one algorithm for performing the encryption of a plain text into a ciphertext by making use of a key. So when you want to define the decryption algorithm, what you have to do is you simply reverse the process. That's it. So a decryption algorithm will become the inverse of the encryption algorithm, right? And since it is symmetric key, what do you understand by this symmetric key? In the first slide itself I told what is the use of this symmetric key cryptography or algorithms.
Uses same key, sir.
Right, both encryption and decryption uses same key. The point should be very clear, right? It uses same key is not giving any meaning. So you should tell that the encryption and decryption both makes use of the same key, secret key. Such type of algorithms we call them as symmetric key algorithms, right? And for example, I told that what is the size of a block? As an example, what could be the size of the block?
64 bits, sir.
64 bits.
or more.
For example, I have only 50 bits of data to be transferred. But every block should be 64 bits, right? But I have only 50 bits of data. So what should you do? You should fill the blocks, the remaining. How many bits are remaining here? 14 bits. So all these 14 bits has to be filled with dummy data. So filling up of the bits with dummy data is called as padding. Have you ever heard of this term padding? Do you know what is this padding?
No, sir.
No, sir.
Right. So it is a new term which you have come across here. Padding is a technique where you will fill the bits with dummy data. Right. So here is an example. When you have less number of bits to form a block, actually I need a block to have 64 bits, but I have only 50 bits. So the remaining 14 bits, in order to form a block, it is mandatory that you should have 64 bits. So the remaining 14 bits should be filled with dummy data, and that technique of filling the bits with dummy data, we are calling it as padding. Is it clear? So this particular point is discussed in that one. If the message has fewer than n bits, padding must be added to make it an n bit block. What is the other case? The case 2 is if you have more than n bits. So actually my n here is 64, but assume that I have 128 bits. So what should I do here? Can I frame a block with 128 bits? Can I frame a block with 128 bits?
No, sir.
No, sir.
No, right. Why? Because I have mentioned that my n is 64. Therefore, I should frame blocks with only 64 bits. So in this case, but I have 128 bits of data to be transferred from sender to the receiver. So in this case, what you have to do is you have to apply the technique called division. So you divide this given block or given number of bits into 2 blocks. So 64 bit is one block and the other 64 bits is another block. That's it. Nothing more than that. Right. For example, now tell me, I have 130 bits of data. How many blocks I will get if n is equal to 64? How many blocks I will get?
3 blocks, sir.
3 blocks. Super, right? So the first block consists of how many bits?
64.
64 bits. The second block consists of how many bits?
64, sir.
64 bits. So 64 plus 64, 128 is completed. We are left with 2 bits. So you should frame or you should form the third block that consists of 2 actual bits of data. And what is the remaining size?
62, sir.
62.
62,
What you
sir.
should do with these 62 bits?
Dummy bits.
you should fill it with dummy data, which is called as padding.
Padding.
Right. So this is how you are going to do it in the block ciphers. Block cipher, remember that a block is nothing but a combination of bits. I'm just summarizing the things, right? A block is nothing but a combination of bits. It can be n bit block. N represents, in general, it will go with more than 64, right? And every encryption and decryption should have a k bit key, secret key. And both encryption and decryption makes use of the same key. Why? Because we are discussing the concept of symmetric key cryptography, where both encryption and decryption makes use of the same key. Right. When we have less number of bits to frame a block, you should use a technique called padding, which involves the filling up of the bits with dummy data. And when we have more number of bits when compared to that of a block size, so you make use of a technique called dividing, where the last block can be appropriately filled with the padding technique. Right? Is it clear up to this block cipher introduction part?
Yes, sir.
So here you can observe the block diagram of the modern block cipher. The name itself is given like this. If you observe this one, it is a modern block cipher. I know what this cipher is. I know what is this block is, a combination of bits. So this technique is not recently, it is a new technique. So that is the reason why they have given the name as modern block cipher, right? So this is from the sender side and this is from the receiver side. So what the sender has to do in order to send the plain text? Can he send the plain text directly? Right.
No, sir.
For example, assume that sender is in Kakinada and he wants to send some data, confidential data. Let us assume some military data to a receiver who is situated in Delhi. Right. So if the sender sends confidential data as a plain text, what is this channel called? How this sender and receiver are connected? What is this line called as? Any idea?
Communication channels.
Communication network, sir.
Super. It is called as communication channel. So what could be the communication channel?
Internet, sir.
Internet, right? So when the sender wants to send some confidential data through a communication channel via the internet to the receiver who is located at Delhi, he cannot send the confidential data as it is. So when he sends the confidential data as it is, some other person, third person, like the intruder may attack the internet and he can get the confidential data. So that should be avoided. So in order to avoid this thing, what they have to do is the sender has to convert the plain text into a ciphertext, which even though the intruder, you can send the ciphertext over the communication channel. Why? Because even though the intruder has got the ciphertext, he is not aware of what the actual text is. Right. So for this purpose, the sender has to convert the plain text into ciphertext. So as I told, that one technique that is used to convert the plain text into ciphertext is nothing but the encryption. And what is that I need for the encryption? I need a key which is of k bit size, right? So once you apply this encryption algorithm with the k bit key on this n bit plain text, you will get n bit ciphertext. You just pass that n bit ciphertext over the internet, and at the receiver end, the ciphertext, when it is received, he has to decrypt it. That means he has to convert the ciphertext into the plain text to get the meaningful plain text. So he has to apply a technique called the decryption, where decryption is a technique which converts the ciphertext into the plain text. So for decryption also you need to have a key. Am I right or not?
Yes, sir.
So decryption makes use of the same key, which is a k bit length, and it will apply this decryption algorithm on the ciphertext, and the receiver will get the n bit plain text. So this is how the block cipher is described. And tell me, what is this one? Is it symmetric or asymmetric?
Symmetric, sir.
So this is a symmetric key block cipher. The inner implementation is not shown here, right? So the n bit plain text is divided into n number of blocks of each block consisting of n bit. That is a different case. But how this is going to happen in the modern block cipher, and that too in case of symmetric block cipher, is explained with this block diagram. Is it clear?
Sir.
Yes, sir.
Right. Now tell me, this is an example we have. So how many padding bits must be added? Listen carefully. How many padding bits must be added to a message of 100 characters if 8-bit ASCII is used for encoding? So how many characters are there? How many characters the sender wants to send?
100 characters, sir.
100. So each character is encoded as 8-bit character, ASCII character, right? So total how many characters are there? One character is 8 bits. So how many bits I have here? Total I have 100 characters. So I have 100 into 8, that is equal to 800 bits. Is it clear up to this point?
Yes, sir.
Yes, sir.
And the block cipher accepts blocks of 64 bits. So what is my block size here? What is the value of n here? 64. Right. Now tell me. He is asking how many padding bits are required. So how can I do, how many blocks are required? First of all, tell me.
Twelve blocks, sir.
Okay. So you have to divide it, right? 800 mod operator you apply. So what is the remainder you get? So how many blocks you have to know means you have to take the upper value of 800 or the seal of 800 by 64. What is 800 by 64?
12, sir.
Sir.
It is 12.5 amma. It is 12.5. That means total number of blocks that are required are 13. Why? Because I have to take the seal. Seal means upper value you have to take. So this is seal of 12.5. That is equal to 13. So the number of blocks that are required are 13. But the last block is not completely filled. Why? Because what is 12 into 64?
128, sir.
12 into 64 amma. 768. 12 into 64 is 768.
768, sir.
So how many, that means 768 bits have been grouped into 12 blocks. What is the last block? 13th block consists of? It consists
32.
of 800 minus 768 bits. So what is 800 minus 768?
32, sir.
32, right? So 32 bits are there for the actual data. In the 13th block, I have 64 bits. Out of these 64 bits, 32 bits consists of the actual data, right? And what about the remaining bits? Those are nothing but the padding bits. Padding bits. Am I right or not?
Yes, sir.
Yes, sir.
So he is asking us how many padding bits are there. So the padding bits that are required are 32. Is it clear?
Yes, sir.
Yes, sir.
Now coming to the concept of substitution and transposition. Right. We know what this substitution and transposition is. Substitution is a technique where you will replace the character with the other characters or symbols, whereas transposition is a technique where you will just exchange the positions of the characters, or you will just change the position of the characters, right? See here. So what technique that should be used for the modern block cipher? I know what this modern block cipher is. I know what cipher is. I know what block cipher is, and I know what modern block cipher is. So modern block cipher makes use of symmetric key algorithm, right? So the modern block cipher can be designed to act as the substitution cipher or the transposition cipher. So you can make use of the substitution, or you can make use of the transposition also. Is it clear?
Yes, sir. Yes, sir.
So the substitution cipher, as I told, that a 1 bit or a 0 bit in the plain text can be replaced with 0 or 1. Anything is possible, right? So let us take an example here. This example is very important. Please concentrate, right? So a 64-bit plain text block consists of 12 zeros and 52 ones. How many zeros are there?
12, sir.
12 zeros.
12 zeros, and you have 52 ones, right? And after applying this substitution cipher, the encrypted or you apply the encryption, the cipher text consists of 34 zeros and 30 ones, right? In the plain text also, I have 12 plus 52, that is 64 bits, and in the cipher text also I have 30 plus 34, which is equal to 64 bits. Both are having, the input text is having 64 bits and the cipher text is also having 64 bits. Nothing, no doubt about it, right? But if you observe the number of zeros and ones, if you observe the number of zeros and ones, how many zeros are there in the plain text?
12 zeros, sir.
12,
12.
sir.
How many zeros are there in the cipher text?
34 zeros. 34,
34, right? Similarly, 52 ones are there in the plain text and 30 ones are there in the cipher text. So if the attacker attacks the cipher text, assume that during the transmission of data, the attacker has attacked. But by looking at the block, he will come to know that it consists of 34 zeros and 30 ones. Am I right or not? But by making use of this information, the cipher text, the number of zeros and ones in the cipher text information, can he assume how many zeros and ones are there in the actual plain text? Is it possible or is it difficult? Did you understand my question?
Once again, repeat, sir.
Right. So my question is, the cipher text consists of 34 zeros and 30 ones. This is an example. Even it consists of 50 zeros and 64 ones also. Even it consists of 48 zeros and some x number of ones. Like that, there can be different number of zeros and different number of ones, right? Which is completely irrelevant with the plain text. So if, for example, if the intruder attacks the communication channel, what is that he will get? He will get the plain text or cipher text?
Cipher text.
He will get the
Cipher text, sir.
So by looking at the cipher text, by going deep into the cipher text, he came to know that there are 34 zeros and 30 ones. And by making use of this information, 34 zeros and 30 ones information, can he exactly assume how many zeros and ones are there in the plain text? Is it possible or is it very difficult?
Possible, sir.
It is not possible. Why? Because 34 zeros and 30 ones does not have any relation with the number of zeros and number of ones in the plain text, right? So the substitution cipher, it is going to change the bits from one text to or one point to another point, right? From one value to another value. So even though the ciphertext in the substitution, the ciphertext that is obtained by the substitution cipher has been attacked by the attacker, he will not get the actual text that is present inside the plain text. It is very difficult, right? Is it clear?
Yes, sir.
Yes, sir.
But if you consider the transposition cipher, what do you mean by transposition? I told that it is going to change the position of the bits, that's it, right? So the bits are reordered, that is nothing but the transposed, right? For example, you take the same example. What is that plain text consists of? The plain text consists of how many zeros? 12 zeros and 52 ones. So if you apply this transposition cipher and you get the cipher text, tell me how many zeros are there and how many ones are there. How many zeros are there and how many ones are there in the cipher text? Does they remain the same or they are going to change? Ma, please respond.
Same, sir.
Same, sir.
Yes, transposition means the number of the value of those bits remains the same, but they are going to change its position. For example, I have 1011, this one, right? So 0 may come first and 1 may go here and this one may come here and this one may come here, right? So how many zeros are there in this text? 1 0. How many ones are there? 3 ones. Am I right or not? So after applying the transposition, how many zeros are there?
1, sir.
1
It is
0,
1
sir.
0. How many ones are there?
3 1, sir.
3 ones. So in the transposition technique, you are not going to change the bits. Therefore, whatever number of zeros are there, they will replicate in the ciphertext. How many number of ones are there, they will exactly reflect in the ciphertext also, right? So the number of zeros and ones remains the same, but the order of zeros and ones will change. That's it, right? So now tell me whether if the attacker attacks this ciphertext and he came to know that there are 12 zeros and 52 ones, now can he get any idea of the plain text? Will he get any idea on the plain text?
No, sir.
He will get an idea. Why? Because the ciphertext and the plain text consists of exactly similar number of zeros and ones. Maybe he will not get the exact plain text, but he knows that the ciphertext and the plain text consists of the same number of zeros and ones. Is it clear?
Okay, sir.
So in the substitution cipher, since you are going to substitute one character or one bit with another bit, the number of zeros and ones in the plain text will completely differ from the number of zeros and ones in the ciphertext. But in the transposition cipher, you are just going to change the order of the bits. You are going to reorder it. So the number of zeros and ones in the plain text is exactly similar to that of the number of zeros and ones in the ciphertext. Is it clear?
Yes, sir.
Now tell me which is difficult to break. For example, intruder. Assume that I am the intruder. You have, for example, one group, the girls has used the substitution cipher and the boys group has used the transposition cipher, and I am the attacker. Right, I am the attacker. So which one can be easily attacked? Easily means not that much easy, but out of this substitution and transposition, which is easier to attack?
Transposition, sir.
Transposition. Why? Because transposition ciphertext will give a clear idea of how many zeros and ones are present inside the plain text. Thereby that attacker will come to know how many he may not get the exact plain text, but he will come to know an idea about the plain text, right? So transposition ciphers are somewhat weaker. Is it clear?
Yes, sir.
So when you want to have more confidentiality, or when you want to have stronger cipher technique, which one you will choose? You will choose substitution or transposition?
Substitution.
Substitution, sir. Right. So substitution is stronger than transposition. Right. Now, by looking at this example, you will have a clear idea. So suppose that we have a block cipher where n is equal to 64. What is this n is equal to 64? What is that n is equal to 64?
Size of the blocks.
Block
Super.
size, sir.
This is nothing but size of block, that's it. So you are going to combine 64 bits as a single block, that's it. So if there are 10 ones in the ciphertext, listen carefully. How many ones are there in the ciphertext?
10, sir.
10 ones, right? So how many trial and error tests does Eve? Eve is nothing but the attacker. He is a personality that we regularly come across in the concept of cryptography. Like Alice and Eve. Like that you have some particular characters which are very famous in the cryptographic point of view. So you always assume that Eve is an attacker. Right. So how many trial and error tests does Eve need to do to recover the plain text from the intercepted ciphertext in each of the following cases? So what Eve has done is he has, however, he has attacked the internet and he has got this ciphertext, and he is asking, the question is, the cipher is designed as a substitution cipher. The same thing I have asked in the earlier slide also. So how many trial and error tests has to be made in the substitution cipher, and how many trial and error tests has to be made by the Eve to get the exact text if it is ciphered by making use of a transposition cipher? So in the first case, is it possible? What is the first case?
Substitution cipher.
Substitution. Case 2 is transposition. Right.
Transposition.
So in the earlier discussion also, the substitution cipher, even though consists of 10 ones, the ciphertext consists of 10 ones, the Eve cannot have exact idea of how many exact zeros and ones are present in the plain text. Why? Because it is a substitution. The number of zeros and ones vary from the plain text to the ciphertext. Right. So in the first case, where Eve has no idea of how many ones are in the plain text. Why? Because they have used the substitution technique. Right. So Eve needs to try all the possible 2 power 64 combinations to get the idea. Right. But in the second case, since they have used the transposition cipher, the Eve came to know that okay, there are exactly 10 ones in the plain text also. Why? Because the ciphertext consists of 10 ones and the same happens in the plain text also. So he will come to an idea that the plain text consists of 10 ones. Now what Eve can do is, there is no need to check all the 2 power 64 possible combinations. It is just enough to check the combinations are the 64-bit blocks that have exactly 10 ones. Right. Not every 64-bit block or 2 power 64-bit blocks need not be checked. So out of 2 power 64, you have to just separate out the blocks which consists of only 10 ones, and from there you can get some idea. Right. So which is easier to break? Is it the substitution or transposition? Listen to my question. Which is easier to break?
Transposition, sir.
Transposition is easier to break. Which is stronger cipher? Is it substitution or transposition?
Substitution, sir.
Substitution. Right. So keeping this in mind, So I think time is up. So this is what we have discussed in today's class. We have started our discussion with the stream cipher, and we have went to the stream cipher or the character cipher versus the block cipher. Why the computers are more interested towards this bit and bit ciphering or stream ciphering, but why the modern symmetric ciphers has moved to the blocks. So what is a block? We have discussed it. A block is nothing but a combination of n bits where n can be any value, but in general we will consider a 64-bit block as a preferred block, right? More than that bits also can be framed to form a block. That is not a issue, right? After that we have gone through the substitution and transposition cipher, and then we have seen some examples also. So we will put an end of this discussion, and we are going to discuss the block ciphers as permutation groups in the next coming session, right? So I think is it clear?
Yes, sir.
Yes. So let us stop our discussion. This is end of today's session. Thank you one and all.